So in this section, we're going to solve an absolute value inequality. Absolute value inequalities are very much like absolute value equations. The only difference is that absolute value equations have an equal sign, and absolute value inequalities will have an inequality symbol. And these equations can take on 4 different forms as shown in the table below. Now, the first 2 forms is when you have the absolute value of some number, where you have the absolute value is either less than, or if it's less than or equal to, that will be considered an AND equation. And so what you're going to do is you're going to place whatever numbers that were inside the absolute value symbol, they will be in the middle, and you will have your constant on both sides of the equation, both the negative and the positive of that constant. Okay, again, that's the case for both the less than symbol and the less than or equal to symbol. The other scenario is if you have the greater than symbol or greater than or equal to symbol. In those instances, these are considered OR equations, and you're going to have 2 separate equations, both the negative and the positive of it. And then also your signs will be in different directions. So in other words, if you have the absolute value of AX plus B is greater than C, that's going to be your same equation without the absolute value bars. And then you're going to have another equation where it's the same thing, except you're going to change the sign and change the symbol. So one kind of stays the same, it's just without the absolute value bar. The other, change the sign, change the symbol. And that's the same case for both when you're dealing with OR equations. So to solve a linear absolute value inequality, you must first write it as an equivalent compound inequality. Now, you may not have understood that whole compound inequality rules that I spoke about in the previous slide. So here's a little hint or a little tip that can help you remember it. The bottom line is you're going to be dealing with an equation that is either going to be an AND equation or an OR equation. And here's how you can tell which one is that. So if you think of a number line or an arrow, and so if you are moving on the number line and you're moving to the right, the greater your numbers are. So this greater symbol you see here, whenever you see that, that's an OR equation. And the more you go to the other end, the less your numbers become. This is a less than symbol, and your numbers get smaller. So I'm going to spell these 2 words, less and greater, wrong on purpose, only to make a point of that one is an AND equation and the other is an OR equation. So let's begin here with the less than symbol. If I spell that wrong, less than, so that I can put the AND in there, less than. Anytime you see a less than symbol, just know that that is an AND equation. And on the other side, you have the greater than symbol. If I spell that wrong, greater with OR, I will know that anytime I see the greater than symbol, that is an OR equation. So that's just one little tip to help you remember when you're dealing with an AND equation, or if you're dealing with an OR equation. Graphing inequalities. An inequality is a mathematical statement that compares two expressions that are not equal by using an inequality symbol. Less than, this is a less than symbol. Next, you have a greater than symbol. This symbol is less than or equal to, and then you have greater than or equal to. One easy way to remember is that if you see a line underneath it, then that's going to be, it's going to have that or equal to attached, versus the other is either just less than or greater than. The other thing to remember when you're dealing with less than or greater than, that means it's an open circle, which means it will not include the number. When you have that or equal to attached to it, then that means it does include the number, which means you would have a shaded or closed circle. These are some examples of inequalities. Again, with inequalities, they will have an inequality symbol in them versus equations that have an equal sign. Inequalities, you won't see an equal sign. Instead, you have an inequality symbol, which really directs you on how you're going to graph the equation. So again, if you have the greater than or less than symbols by themselves with no line underneath, if you're going to graph, it means you will graph with open circles, or another method is you will use parentheses to indicate that it does not include the number. The other inequality symbols is where you have greater than or equal to or less than or equal to. And you know the difference is that it has that line underneath, that equal line. In those instances, that means it does include the numbers. In terms of graphing it, it will be graphed with a shaded or colored in circle, a darkened circle there, or you can also use brackets. Brackets also indicates that it does include the number. And you'll see what I mean by including a number versus not including a number, what that means in the coming slides. The other thing that you need to remember is that when you see the greater than symbol, that means that your arrow is going to be moving in the direction of positive infinity. And on the other hand, if you see that a less than symbol, that means that your graph is going to be moving toward negative infinity. So again, think of it as that symbol is sort of like an arrow that basically directs you to which direction of infinity your line will be going. Okay, so before we begin graphing absolute value inequalities, I want to do two problems on just regular graphing of inequalities, because once you see how to graph inequalities, how to solve them and graph them, you will understand how to solve and graph absolute values even more so. So with any equation, your goal is to solve for x. So our first step towards solving for x is to subtract 3 from each side. That's going to leave me with 4x on the left side and negative 12 on the right side. Last step to solving for x is to divide by 4. What we do to one side, we do to the other. Negative 4 divided, negative 12 divided by 4 is going to be negative 3. And so x, we use our inequality symbol to read the statement. X is greater than negative 3. Now, because you don't see a line here, that means it does not include negative 3, which means when we graph it, we're going to use an open circle. So Let's get our number line, and at -3, you're going to have a circle that is open. Our arrow tells us that this graph is going to be moving to infinity to the right. And so we place our arrow there, and it goes on and on to positive infinity. Now, to write it in interval notation form, it's easy to write it once you look at your graph, because of the fact that it does not include 3. At that point, we're going to have a parentheses, -3, comma, and going all the way forever to infinity. And remember, infinities are always closed with a parentheses. And so that is how you would write it in interval notation form. Again, parentheses, -3, comma, positive infinity, close parentheses. And there you have it. That is how you would solve and then graph a regular inequality. Let's do one more. So we want to solve for x, or in this case it's n. So the first step towards solving for n is to combine like terms. Let's get our variables together on one side and our numbers together on the other. So I'm going to go ahead and bring my variables on the left side. So I'm going to subtract 2n from each side. And I'll bring my numbers over to the right by adding 7 to each side. Now we can go ahead and combine them. 8n minus 2n equals 6n, and 7 plus 5 is 12. So what we have is 6n is less than or equal to 12. Our last step to solving for n is to divide by 6. Whatever you do to one side, you do to the other, and n equals 2. Or n is less than or equal to 2 is the correct way to say it. So now we're going to go ahead and graph that. So at 2, this time, instead of an open circle, because you see that line underneath there, it has that or equal to attached. That means it does include the 2. So I'm going to color in my circle. And the inequality symbol tells me that my arrow is going to be pointing toward negative infinity. So I'm going to go ahead and graph our line, and it's going to look like so. To write it in interval notation form, we're going to have a bracket on this end. Whenever it includes the number, we use a bracket. And then we're going to have 2, comma, and then in the front you're going to have negative infinity, because it goes on and on to negative infinity. And remember, on the left side of the enclosure, you're going to put a parentheses, because all infinities are closed with a parentheses. So you'll have a parentheses on the left side and a bracket on the right. So it's going to look like so, parentheses, negative infinity, comma, 2, bracket. And there you have it, solving a inequality statement. Okay, now we're ready to start solving absolute value inequalities. Recall, you're going to be dealing with 2 different types of equation. You're going to either have an AND equation, or you're going to have an OR equation. So all we have to do is look at our symbol. Notice our symbol, the arrow is pointing toward the greater n, greater, or, so that means that this is an OR equation. And recall, with the OR equations, you're going to have 2 separate equations. You're going to have whatever is within the absolute value symbol, and you're going to have the positive of that constant, and then you're going to have the negative of the constant. Now remember, one of the equations will be exactly the same, including the symbol, so it's going to be x plus 9 is greater than 3. And then you're going to have another equation where you're going to have x plus 9. Now we're going to change the sign, change the number. The other one is going to be less than -3. So it's going to look like so. Again, with the OR equations, one will be exactly like the original equation minus the bars. The other one, you have to remember, change the symbol and change the sign. After you do that, it is just a matter of simply solving for x. So let's start with this first one. To solve for x, all I need to do is to subtract 9. So let's go ahead and subtract 9. Once we subtract 9 from the -3 we already have, that's going to give us x is less than -12. For the other one, we also need to subtract 9 from each side. And when we subtract 9 from each side, what we're going to get is x is greater than -6. And now it's time for us to graph it. When we graph it, again here, it does not include the numbers, so we use open circles. So you'll have an open circle at -12, and you're also going to have an open circle at -6. This symbol tells me to that it's going to go to positive infinity. Our arrow is going in that direction. And the other symbol tells us that our arrow is going to be going to negative infinity. Okay, so one's going to positive infinity, and the other will be pointing toward negative infinity. And there you have it, absolute value inequalities. Oh yes, one other thing. Let's write it in interval notation form. So to write it in interval notation form, remember infinities, you always close those with a parenthesis. So that's going to be parentheses. And then it's going to be negative infinity, comma, stop at 12. Does it include 12? Nope. So we use a parenthesis. Then use the union symbol, which is like a U. And then we come back to -6. Does it include 6? Nope. So let's use a parenthesis. -6, comma, all the way to positive infinity. And we always close infinities with a parenthesis. So when you write it in interval notation form, it's going to look like so. So parentheses, negative infinity, comma, -12, close parentheses, union, parentheses, -6, comma, infinity, close parentheses. And there you have it, an absolute value inequality. In this next example, let's take a look at our symbol to see what type of equation we're going to be dealing with, whether it's and or. Here we have a less than symbol, so less than and, that means this is going to be an and equation. And with the and equations, you're going to have whatever you see in the absolute value symbol here, x plus 1, you're going to have that sandwiched in the middle, and on each side you're going to have both the negative and the positive of our constant. So all this we already have, less than 8. All we need to do is put that same symbol on the opposite end and put -8. So when we do so, it's going to look like so. Our goal with any equation is to solve for x. Right now, guess what? 1 is with x. We got to get rid of that 1. So let's go ahead and subtract 1. But we have 3 parts to our equation, so that means we're going to subtract 1 from all 3 parts of our equation. So when you take 1 from 8, you're going to have -9. Subtract 1 from this 1, and it's gone. Subtract 1 from the 8, and you have 7. So x is going to be between -9 and 7. So let's see what that looks like on a graph. Notice that there is no line underneath, so it is not going to include either one of those numbers. They're going to be with open circles, so there you have it. And to write that in interval notation form, remember when it does not include the numbers, we use a parentheses on each end. So what you're going to have is parentheses -9, comma, all the way to 7, close parentheses, and there you have it. All right, we have another equation. Let's take a look at this equation to see specifically at our inequality symbol, because we want to know if is this an and or is it an or. So I'm going to ask you, what is it? If you said that this is a less than symbol, less than, therefore it is an and equation, then you are absolutely correct. So recall with an and equation that you're going to have on both sides of the equation that constant, both the negative and the positive of it. So all you're going to do is remove those absolute value bars, and then on the other end you're going to place that same symbol, but you're going to have -7 on that left end. So let's go ahead and write that. When we do so, it's going to look like so. We want to solve for x. Right now, 1 is on the side with x, so we have to subtract 1 from all 3 parts of the equation. So once we do so, what we're going to wind up with is -8 and one end, and on the other end we have 6. Okay, so one way you could also read it though is, but we're not finished solving it, so it really doesn't matter, but here 2x is greater than -6 or 2x is less than 6. But at either case, we still have to solve for x. So what is it that I need to do to get x by itself? Well, right now, x is being multiplied with 2. So to get rid of it, I have to do the opposite, which is divide. Divide by 2. And if I'm going to divide the middle part by 2, I have to divide all 3 parts of the equation by 2. So when I divide all 3 parts of the equation by 2, I am left with an answer of that x is between -4 and 3. So again, it does not include either of those numbers on either side, because notice you don't have that line underneath. So you're going to go ahead and put open circles there. And then simply write it in interval notation form. So you know when it doesn't include the number, we use parentheses, so that's going to be parentheses -4, comma, all the way to 3, close parentheses. And that's how you would write it in interval notation form. Okay, so we have another absolute value inequality. Let's first look at our symbol, inequality symbol, to determine whether this is an and or equation. So what do you think? Okay, so here we have greater or equal to, and because it's greater, it's an or equation, which means we're going to have 2 separate equations. So we're going to have the positive of that constant and then the negative of that constant. So we'll have 2x plus 5 is greater than or equal to 3, or 2x plus 5 is, and remember we have to change the sign, change the symbol, so it would be less than or equal to -3. And let's go ahead and solve for both equations. You're going to have to subtract 5 from each side. So we'll go ahead and subtract 5 from the first equation. That's going to leave us with 2x is less than or equal to -8. Last step to solving is to divide by 2. And x equals less than or equal to -4. For the other equation, again, we have to subtract 5 from each side, then divide by 2, and x equals greater than or equal to -1. And so now it's time to graph the inequality. And so since it does include the number, and we know that because you notice you have that or equal to attached to it. So on both ends, you're going to have a bracket instead of a parentheses when you write it in interval notation form. And when we graph it, we're going to have colored circles. So let's go ahead and graph it first. So at both ends, notice you see here that it has been colored in to indicate it does include -4 and -1. And then writing it in interval notation form, we're going to put brackets at the -4 and at the -1. And then it's going to move in either direction to infinity. And then just remember that these infinities are always closed with a parentheses. So to write it in interval notation form would be parentheses, -infinity, comma, -4, bracket, union symbol, bracket, -1, comma, infinity, close parentheses, and there you have it, absolute value inequalities. Okay, let's solve this absolute value inequality. What do you notice about this equation? Well, for one, you have the absolute value symbol. It's not alone. -1 is on the side with it. So that's going to be step one, is you're going to have to add 1 to each side so that you can isolate the absolute value symbol. So let's go ahead and do that. And by the way, what type of equation are we going to be dealing with? Is this an and or is this an or? All right, so if you said greater or, then you are correct. All right, so let's go ahead and add 1. All right, so now that we've added 1, and this is a greater equation, we know that we're going to have 2 separate equations. One is this equation itself without the absolute value bars, so that would be 2 minus 7x is greater than 5. And then recall the other one, the only difference in the other one is that you're going to change the symbol in the opposite direction and change the constant number, which is 5 in this case, change that to its opposite. So the other one is going to be 2 minus 7x is less than -5. And then we need to go ahead and solve these two equations. So for either one of them, you're going to have to subtract 2 from each side. And then after we do that, we're going to have to divide by -7. So let's start by subtracting 2 from each side. Now, the next step then is to divide by -7. Anytime you have to divide or multiply by a negative in order to get your answer, you must reverse the symbol in the opposite direction. So what you're going to wind up having then is -7x is less than 3 instead of greater than 3. We also need to divide that by that -7. So what we have as our final answer there for the first equation is x is less than -3/7. Again, we changed the symbol direction because we divided by a -7. And the same is going to go for the second equation. Yes, we have to subtract 2 from each side. Then we're going to divide by -7. And again, because we're dividing by a negative, we have to turn the sign in the opposite direction. And so what we'll wind up with is x is greater than 1. Let's go ahead and get ready to graph those. So notice that you don't see that or equal to underneath or attached to these. So that means that it is not going to include these numbers, and at that point we're going to have what is an open circle, and that our arrows are going to be pointing to infinity and two opposite ends there. So it's going to look like so, and then accordingly you would go ahead and proceed with writing it in interval notation form, which would be parentheses, negative infinity, comma, negative 3/2, close parentheses, union symbol, parentheses, 1, comma, positive infinity, close parentheses. And there you have it. So always remember that rule. Anytime you have to multiply or divide by a negative in order to get your answer, you have to reverse the symbol in the opposite direction. In this last example of absolute value inequality, I want to show a special case here. So step one, you can look at the inequality symbol to determine whether this is an and or whether it's an or. So notice it's less than, so it would be an and equation. But before we do anything else, we need to isolate the absolute value symbol. So let's go ahead and proceed by subtracting 1 from each side. And once we subtract 1 from each side, we're going to have the absolute value of 3x minus 7 is less than negative 3. Now recall the rules for absolute value here is the problem is the absolute value of a number cannot be a negative, so it cannot be less than 3. And because you're saying that the absolute value is equal to something that is less than 3, there's no solution because the absolute value again of a number cannot be a negative. So there's no solution.